Hey everybody, this is Mr. Brooks. Today I'm going to go over the polynomial notes, and we're going to do some polynomial vocabulary, and we're also going to add and subtract polynomials. This will be the first part of the polynomial unit. And the learning target for today is I can add and subtract polynomials. We're also going to go over the vocabulary, and I want you to get that as a base. On the test, you'll have to know how to add and subtract, but in order to really do this, you really got to speak the language. So also on this is also vocabulary. All right. Today we're going to talk about polynomials. What are they? And then we're going to talk about simplifying polynomials. So polynomials is two words. It's poly, or I guess it's a prefix, and nomial is a number. So it's many numbers. And that's kind of a literal translation. It's really a polynomial is many parts stuck together to make a big number. And so, if you just have one number, like for example 5 or x squared or 2x, then it is a monomial. It's just a number. And if you have 2x squared plus x, as we're going to see, those are not like terms, so you have a polynomial. There's more of them. All the terms in a polynomial are separated by pluses and minuses, and so that's what we're going to be using to distinguish for how many parts. And then you also need the same vocab for foundations, which is like, what is a term, what is a coefficient, what is the exponent, what is a variable. And then for simplify, there's just two parts. The two parts for simplification are distributive property and combine like terms. Okay, so that's what we're going to do today. All the rest we'll do later. Here is your vocab chart right here. Okay, so 5 is a constant because it's actually x to the 0, which means the degree is 0 or the coefficient is 0. And it is a monomial because there's only one. Okay, but it's right here. There's two of them, and it's a binomial. And you might remember this as like mx plus b, so it's linear, and we've worked with linear before. Okay, and then next would be this is a monomial, but it's also quadratic because it's the second power, so the degree is 2. That's talking about the exponent, and the number of terms is 1. Whereas this one, you've got 1, 2, 3 terms, so 3 terms, and the degree is also the coefficient. I'm sorry, is also the exponent, and that makes it degree 3, which is cubic. Okay, so here is a degree of 4 or a quartic, but it's only a binomial because you have 1, 2 parts. Bi meaning 2. Okay. All right. So study that chart every day. You should be able to match them. You can make flashcards. You can read it every day, but you should have a grasp of this vocabulary before too long into the unit. Okay. Here's the most important thing to understand, and this is all from foundations unit, but this is the knowledge I want you to carry over, or I guess it's called background knowledge or schema. Okay. And that's just this. If you have x plus x, where you add two numbers together that are like terms, so they're both x to the first, then it's 2x. Okay, so what you've done is you've added the coefficients, because remember, when it's just x, it's 1x plus 1x. 1 plus 1 is 2. Notice that the exponent did not change. What's the exponent? Well, the exponent you don't write because it's 1. If the exponent's 1, you don't write it. And this is to the first, and this is the first. So when you add and subtract, the exponent does not change, okay? But if you multiply, so x times x, then you get x squared. All right, so what did we do? Well, we didn't add the coefficients, we added the exponents. So for example, in this case, the exponent is 1, 1, and 1 plus 1 is the 2 right there, okay? All right, how this is applied. If you have something like x cubed plus x squared, then these are not like terms, and you cannot do it. You just rewrite it as is. But it's not x to the fifth. It's not 2x to the third. It is just what it is. You can't combine like terms. You can't combine unlike terms. Okay, but if you have x cubed times x squared, okay, so now we're multiplying, then like terms don't matter. All you have to do is add the exponents. So this would be x to the 3 plus 2 is 5. All right, sorry the handwriting is so bad. Okay, here we get to addition. And what I'd like to show you is called box and bag. And to do box and bag, what you do is you put a box or some kind of shape or underline or some mark around one of the terms, and you're like looking for like terms. So to the second, between these two, this is 2p to the second. Again, I'm looking at the exponents, but 5 plus 2 is 7p squared. Just like we talked about, you don't change the exponent. And then right here, I'm going to pick this one because it's a bigger exponent, but it'd be negative 3p. And notice there's no more cubics right here, so there's no more to the third power, so it's the only one. And the 7p squared is positive, so you separate with a plus. Remember, we're going to separate all the terms with a plus or minus. Okay, and then in this case, it's really easy because it's very short, but there's just a negative 3. Notice I'm grabbing the negative, and so it would be negative 3. Okay, so this is a trinomial. Oh, I'm going to put it as a cubic trinomial. Okay, why is it cubic? It's cubic because the degree is 3. It's trinomial. I can't talk. Right, trinomial. All right, it's cubic because the leading term coefficient is 3. I'm sorry, the leading term exponent is 3. And it is a trinomial because there's 1, 2, 3 parts. Okay? Remember, when you classify a polynomial as either linear, quadratic, or cubic, or quartic, it's always the leading term. It's the first one, and that's why standard form is important, because standard form says you always put the highest exponent first. Like it'd be like to the fourth, and then to the third, and then squared, and then 1, and then just a constant. Standard form says you always put the highest exponent first, left to right. Okay. Okay, here's one more. And this time it's a little more out of order, but this is to the third and this is to the third. So 5, 6, 7 in cubed, and this is 4 and 2. And I'm using circles because colors, but again, like you should use triangles or underlines or squares or things that are different, so you can tell them apart. And the other thing you can do is after you do it, you can just take it off, and that way you don't get confused. 4, 5, 6, so 6. What is this? This is a cubic, but it's not a trinomial. It is a binomial because there's 2 parts. Okay, is there another way to do this? Of course, there's a million ways to do this. Let me show you one more real quick, okay? I'm going to erase some of my markings so we can have a fresh palette somewhat. And I'm going to rewrite it vertically. And what I'm going to do is I'm going to write them in standard form, and I'm going to match up in columns all the different types of polynomials. So it would be 2n cubed plus 4. Now keep in mind, this is commutative property. It doesn't matter if you say plus 2. It doesn't matter if you say 4 plus 2n or 2n plus 4. It's the same, right? You can commute. You can move the terms for addition. Okay. And then this is going to be plus. And I squeezed myself a little bit, but it's 5 into the third. And notice all these are in a row. Plus 2. And then you just add down. So add 2 plus 5 is 7 into the third. and then this is plus 6. And what you don't want to do is you don't want to add a quadratic to a cubic. Like, you might leave a space or put a 0 there when you add to make sure it's right, okay? All right. So the next one is subtraction, and subtraction is harder. And if we were to think about this as just subtraction, let's go through this once and we'll see just kind of how many opportunities for mistakes we have. I'm going to start with the highest power, so a to the third, and it's minus a negative. This is our like terms right here. So it's a to the third minus a negative. So all of a sudden, I'm going to keep track of all this, and I'm going to have to say minus a negative means plus. So a to the third minus negative 4a to the third is positive 5a to the third. Okay, nothing's changed. I'm still following the rules. I didn't change the exponent. But I am making sure I'm subtracting it. In other words, it would be like a cubed minus negative 4a to the third. And so, this right here, this is going to be plus, right? Okay, and then negative 2a squared minus 3a squared, that's negative 5a squared. And you can see how students will know what to do, but they will make a silly mistake. So that you can always do it that way, but let me show you another way, okay? What I'm going to do in order to make this really easy peasy is I'm going to flip change, or change the rest, okay? What you do is you flip the sign to plus. So I'm going to change this to plus, all right? And then I'm going to change all the signs. So this is going to be negative. I might have to write this out. And this will be plus. I'm going to keep it. Okay. So what I've done is I've turned it from a subtraction problem into an addition problem. And in order to make that true, I'm going to have to change all the signs of what I'm subtracting. Okay, and that works if you think about it. So now it's the same exact thing as addition. And now there's no signs to mess up. So a to the third and positive 4a to the third is 5a to the third. Hopefully you'll see this as easier. And then over here is negative 2a squared and negative 3a squared, which is negative 5a squared. That's the same thing we got last time. But if you flip change, or however many you got, then that might make it easy, okay? Okay, feel free to pause the video here and try it yourself and see if you have the same thing I get, okay? Okay, if you tried it, awesome. If you didn't, we're going to see it. So what I'm going to do is I'm going to flip the sign, and I'm going to make this negative, and I'm going to make this negative, I'm going to make this positive, okay? And now I'm ready to box and bag. So I've got negative 3 into the fourth, and negative 11 into the fourth, and that's negative 14 into the fourth. Okay. And then what else do I got? I got 10n squared and negative 3n squared. Notice, like, this negative, it changed. It was positive, but now it's negative because we flipped the sign. So this is positive 7n squared. Okay, and then now we have this guy right here, and there's no more. The 7 is not the same thing. I'm going to say plus 8n, and I can tick these off if I want as I go, so I don't get confused. And then the last one is this guy right here, and it's plus 7. So we have a polynomial, a 4-part polynomial, that's quartic, the 4th degree, okay? All right, that is adding and subtracting polynomials. Good luck, and let me know if you have any questions.